Welcome to Filtration Matters, a regular podcast from BOFA, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and extraction system design are helping improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts will discuss how advances in extraction technology are helping optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today, we're looking at the important interaction between temperature control and fume and particle extraction in additive manufacturing. We know that 3D print technology is becoming more sophisticated to optimize the value of new generation material science. Many of these evolving functional materials are designed-in properties such as tensile strength and scratch resistance, but they also need a precise temperature envelope within the chamber. We also know that higher temperatures can increase the volume of emissions that need to be extracted from the process, both to ensure a clean print environment and to help maintain a healthy workplace. To understand how this need for fume and particle extraction can be achieved while maintaining optimal chamber conditions, I'm joined today by Shravya Nahar, a product manager at BOFA, who has specialist knowledge of additive manufacturing and extraction technology. Welcome, Shravya.
Thank you so much, Philip. It's great to be here.
Shravya, perhaps we could start by understanding a little about your background and your role at BOFA.
Sure. Firstly, thank you for having me on today. To give you a bit of background about myself, I joined the BOFA team in early 2022 as a product manager. I have a background in bioengineering and have worked in the medical, educational, and consumer product industry, where I was a part of the marketing, quality control, and research and development teams. I grew passionate about finding and applying missing pieces to marketplaces in order to be innovative in industries such as manufacturing and medical devices specifically. Those are the areas that interest me the most. These experiences had provided me a holistic perspective of engineering and entrepreneurship, which I applied to our products and customers to fulfill their needs. I collect customer input and feedback, conduct market research, and identify the latest policies and trends to better define the vision of our product lines.
Thanks, Shravya. So let's create a little context here around the evolution of 3D printing, particularly in terms of the operating temperatures and materials. What's been happening in this market?
So 3D printing has been growing at an expanding rate in the recent years, especially with the onset of the COVID pandemic. Due to restrictions set in place during that time, there were many global supply chain shortages that led to long lead time for components, or you just wouldn't be able to get certain components at that time. This has really pushed forward the rise of 3D printing as it allows for on-demand components that can be made locally. 3D printing today covers a huge range of products, from small businesses producing customized chess sets to the Terran 1 rocket, which recently lifted off from Cape Canaveral in Florida, and this rocket was 85% 3D printed. In recent times, there's been a lot of investment in research that goes into this technology and the materials that can be used with it. So it's a very exciting time for 3D printing, and it's a growing area of industrial technology.
So it seems like 3D print technology is growing, but there also seems to be a lot of innovation going on in material science. What is the sort of innovation that's happening at present?
In effect, multiple sectors have been considering how to use additive manufacturing to stay away from costly tooling and molding associated with the traditional manufacturing processes, to a 3D print world that offers a scalable approach to production and accelerates this design process. But in order for this to happen, they need to weigh the economies of investment in the 3D technology with the product type, the customizations, the volumes, and the supply chain efficiencies to find a sweet spot. It's not just a simple question of swapping one process for another. It can also be about rethinking the possible. Can we 3D print a new product with specific characteristics that we know will satisfy existing customers or help us enter a new market, that's when new generation functional materials come in.
So let's explore that a little further. What do we mean by functional materials, and what sort of properties are we talking about?
Functional materials or high-performance materials, specifically polymers, have enhanced mechanical and thermal properties compared to standard polymers. This includes higher tensile strength, fire retardation, flexibility, corrosive media resistant, and more, and all within strict tolerances. So in recent years, we've been seeing new resins, polymers made in filaments, and metal powders that have been coming to the market with new formulations to be fit for purpose or fit for industry. And a good example of this is PEEK, which is polyether ether ketone, a very high performance and durable material, along with its variants that are used in the aerospace, automotive, oil and gas industry, now crossing into new applications, including PEEK printed medical devices. We've also seen innovation in new eco-friendly plastics using organic compounds such as soybean oil and corn. The industry is aware of the growing customer sentiment towards sustainable materials, so there is a lot of investment that's going into greener material science.
So I understand that many of these materials require higher processing temperatures to achieve the desired product properties. Why is this, and what is the effect on fume and particles emitted during the process?
Chamber temperature control is essential in 3D printing because generally they operate in narrow temperature envelopes from the bed up to ensure that feed material reaches the critical point where it can be layered and bonded without warping or creating overhangs. Likewise, the cooling process must be carefully controlled to avoid, say, the risk of brittleness in certain materials. When it comes to emissions, the concentration of nanoparticles and VOCs emitted in certain materials, in fact, in most materials, is known to increase as temperature increases. PEEK is a good example of a high temperature material, and we know that when PEEK is printed, it needs to be printed at a chamber temperature of 90 degrees Celsius and higher. This material is known to leave even residue of its byproduct inside the chamber temperature, which we don't really see that much of when we print just normal engineering materials for rapid prototyping, such as PLA and ABS. We know that some of these airborne contaminants gives off particles that could interfere with the product quality if not effectively managed. Likewise, some of the VOCs emitted have potential to be harmful to human health.
Which I guess brings us neatly to the role of extraction in the world of additive manufacturing. How does the BOFA system support 3D printing, and why is it needed?
It certainly does. So the BOFA systems are specifically the 3D range that are catered towards 3D printing additive manufacturing, have lower flow speeds when you want to connect to just one printer, or you can use one with a higher flow speed to connect to multiple printers. Because of the nature of the 3D printing, you don't want too much airflow because that could potentially disrupt the print quality. That's why we go with the lower airflow. So what it does is the extraction system will pull out any of the particles that are emitted or any of the VOCs which relate to the odor, pass it through a HEPA filter which will capture any of the particles, and a carbon filter which will absorb the VOCs, protecting you from any of the contaminants that you face while printing.
So let's explore this in a little more detail. How does BOFA ensure that the required operating temperature, which you've mentioned is critical, how does BOFA ensure that that window is maintained throughout the 3D process?
So we have a new product that we're going to be launching soon called the 3D Print Pro HT. The HT stands for high temperature. So when you're filtering air from chambers that are heated up to 100 degrees or higher, even starting from temperatures above 60 degrees Celsius, an important thing that you have to keep in mind is that you don't want to create any loss of heat in the system or create any changes in the temperature in the chamber, because this would disrupt the print, alter the print quality, and this would be detrimental to the customer, because that's not something that they want to face when using an extractor. So we have created a modular system which has a recirculating loop, and then when the print is finally finished, it will pass through the purge loop. So going into some more depth, the recirculating loop will be connected in a closed loop with a 3D printer with an inlet and an outlet. And we have insulated hoses that will prevent any heat loss between the transfer of air from both the systems. So if you have a chamber temperature of, let's say, around 100 degrees, it can pass through the recirculating chamber, which will actively be filtering out any of the particles that are given off during print. However, at this time, you won't be filtering any of the VOCs, and this is because carbon loses its ability to absorb any of these gases at higher temperatures. In fact, it does the opposite. If it has absorbed anything, it spits it out at higher temperatures. So we have the purge unit, which has a combined filter, a HEPA filter, and a carbon filter within it to help capture all of the VOCs that are contained within the 3D print chamber towards the end of the print. So once the print is finished, there's going to be ambient air that is slowly let into the system while air is being extracted out to ensure that there's no negative pressure created inside the 3D print chamber. And the air will be cooled down before it passes through the carbon filter to ensure optimum VOC absorption.
So in this high temperature environment, how does BOFA go about ensuring that the advanced electronics and mechanical components operate as they should?
So this portable system's advanced electronics, mechanical components, and filters are either designed for high temperature environments or they're appropriately insulated. These advances result from a close working relationship between BOFA, 3D OEMs, material technology companies, and end users. This approach ensures that BOFA extraction systems help deliver effective filtration of fume, particulates, and gases to optimize 3D print quality. So getting this relationship right between maintaining a precise operating temperature and achieving effective filtration is critical to helping realize the value of new generation functional materials while delivering a positive return on investment for end users.
Many thanks, Shravya, for your expert insight into the fascinating world of material science and 3D printing, and the vital role that extraction technology is playing in enabling the expansion of additive manufacturing into all sorts of new markets.
And thank you so much for taking the time to speak with me today about the importance of temperature control in 3D printing.
If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.